All right, chapter 3, section 8. We reached the end of functions. All right. Well, the last thing is absolute values, right? So what we're doing here is we're taking a look at a different function, right? We did linear functions. This is a different type of function called an absolute value function, okay? And since we've learned all the vocabulary and tools of characteristics of describing shapes and functions, and we've already learned the tools describing transformation, how a line or any shape can be transformed into something else, okay, using H, K's, negative signs, and A's, right? We're going to apply all of that to our friend absolute values. Okay, so let's start with some basics. This is an absolute value shape. This is our normal shape. It looks like this. This is the equation. This is what it looks like. Okay? And the vertex, right where it little bends, it's referred to as 0, 0. That's the corner, right? Now, what are some characteristics of this shape? First, the domain and range. Now, we could talk about the characteristics, right? The y-intercept, the x-intercepts. We could talk about the positive and negative, the increase and decrease. In this case, we really want to focus on the domain and range. Now, the domain for an absolute value is always the same thing. It's always going to go to the left. It might go slow, it might go fast, but it's always going to go to the left. And the range, on the right-hand side, it's the same. It might go slower, it might go faster, but it's always going to go towards the positive direction. The domain is always this interval. Okay? Now, it happens so often that everybody knows this. I know it, you know it, we all know it now. So oftentimes we'll skip to the middleman and use words and say all the numbers. Okay? Which one of these X is part of the domain? All of them. Every one of them is X. That's every one of them is part of the domain. All the real numbers are part of that. Okay? Now, in this particular case, at our standard, everyday, regular old absolute value X, our range is only up. So our range is always greater than 0. All right. Now, we have what's written, our absolute value written in a format called vertex form. Basically, it's this. Now, this was this. This was the old one, and it became this. What is different about this? Well, I'm going to point out to you what we did last section, right? There's an A in front, but maybe it's 1, so it has no effect whatsoever. There's an H, but maybe it's 0, and it has no effect whatsoever. Maybe it's a K. Okay, either way, these variables affect the original one. This shape is going to move up and down, left and right, and it's going to be stretched out. Okay, so here's what that means. Boom, boom, boom. The vertex is the H and the K. All right, now let's go ahead and take a look at one here. All right, this is a pretty long one, but take a look. Graph the function. Describe its transformations. Okay, describe the domain and range. Here's the function. Now, this blue line right here, this dotted line, this represents our regular everyday function. Okay, this is our laugh here, is our actual what we need to graph. This is our vertex, right? If that's a 1 and that's a 4, our vertex is negative 1, 4. There's our dot. Now, it also has a negative in front, which means it got flipped upside down. So it's going to go upside down. It also has a 3. Now that 3 is what we might call our A number. Okay, that 3 is our A number. And that A number is telling me not only did it move, not only did it get flipped, okay, but our original graph, when everything was normal, had a slope of 1, okay? In other words, we went up 1 over 1, up 1 over 1, up 1 over 1, and that was our slope. Since our A is negative 3, that's our slope. So here's our guy, that's negative 3 over 1. 1, 2, 3, 1. See that guy? And that's our slope. Negative 1, 2, 3, 1. Now, the other part is, okay, we finish because if that's one of them, the other spot is on the other side. I have my vertex, I have my two dots, I have my V shape, and that's what happened. Now, this line is my graph. I needed to understand the three things that were happening to my graph. I noticed it moved up and down, left and right. I noticed it flipped, okay? And I noticed it got thinner. It got narrower by a factor of 3, okay? So it got thinner. Now, what's my domain and range? My domain is always the same, all real numbers. That's not that difficult. And my range is all of the y's less than this number, which had to be 4. Okay? Now, does it include 4? Well, yes, this spot is actually on the 4. It includes the 4. Therefore, it's less than or equal to 4. Now, let's go ahead and try a couple of examples ourselves. First of all, what's the vertex here? If there was an H, it would be on the inside. There isn't there. If there is a K, it would be on the outside. There it is. My vertex. There's my point right there. 0, negative 4. Write an equation that represents this, but moving down 7 points, 7 units. Okay. To show people that it's the same thing, okay, but I moved it down 7, I'm going to put negative 7 in the K spot. That's how I know what the K is. Here on the right, graph the function, this guy. Okay, now, here's my regular graph. I just want to show you that to compare, okay? From here, where is our vertex? Our vertex is negative 2. Don't forget the H is backwards. Negative 2, negative 6. So we go 1, 2, 1, 2, 3, 4, 5, 6. Close enough there. Okay. And from here, okay. Now, does it get thinner or fatter? It doesn't say that. Does it flip upside down? No. So I still have my regular shape. Now, describe the transformation. What happened between here? It started off here, and then it became this. So what happened to it? It moved left 2, down 6. That's what happened. I'm just changing the mathy symbol way of saying it. Okay? I'm changing it to words. Okay? This helps us understand that we're talking about the same thing. Words, mathy symbols, pictures. All three of these are what we need to master and understand, because when we see a picture, we can picture the numbers. We picture the numbers, we know what it means and what it's saying. If we knew what it was saying, we should picture the graph and picture what it looks like, okay? Now, as far as this is concerned, the domain is always the same, all real numbers. And the range, okay, is all of the y's from this spot up. It's all of the y's from negative 6 up. It's all of the y's greater than or equal to negative 6. That's where we're at, okay? Now, if you have any questions on this last assignment for Chapter 8, you go ahead and let me know. Ask another teacher, come to tutoring, email me.